All right, cool. We're talking about percent of change. Here is the thinking question. So obviously on the front of this, you can see it's really big on the notes. It's like, oh, that's the equation we're using. I also put the proportion down in the bottom right-hand corner. It's very, very small. So if you're a proportion person, look at that. Here is what we're looking at today. Last year, there were 888 students at FJH. Then the population exploded. This year, there are 1,010 students at FJH. Was this an increase or decrease? It's an increase, right? It's an increase. So we would want to make sure that we understand, okay? I have to keep clicking. It's an increase. And today we're going to look at by what percent it increased. We are not going to do 1,010 divided by 888. We're not going to do 888 divided by 110. We will have to process the numbers that were given and then do something with them. You won't be able to just use the numbers that are given like we've been doing. We have to think about them. It's kind of like when we've been adding tax and we've been adding amounts. That's what we're looking at for today. So percent of change, read along with me. You've got this definition. It's very important. Percent of change is the percent a quantity increases or decreases from its original amount. Hey, remember original amount? What letter do we use for original amount usually? W. So that's not going to change. Okay? What will change is the A and the P. Remember, if we're looking for percent of change, that's this, then what should A be? Amount of change. So when the population of FGH was 888 and now it's 1,000, the amount of change would be a little bit over 100, right? 888 is pretty close to 900, 1,010 is pretty close to 1,000. So the amount of change wouldn't be 1,000, the amount of change wouldn't be 888. The amount of change would be the two subtracted. And that's what we're going to do, okay? So here, you may want to put like old minus new, or you may want to write new minus old. That's what the amount of change is. It is a subtraction problem. That piece is subtraction. So W is our original number, like it's been. P is going to be percent of change. That means A needs to be the amount of change. And you'll have to find the amount of change. How will we find the amount of change? We'll use subtraction. We'll subtract. Always big minus little, right? Doesn't matter. It's always big minus little. So here we're going to find the percent of change. Then we're going to label it as an increase or decrease. And we'll round to the nearest tenth for these particular problems to make it easier. So we're going from 12 to 20. First off, is that an increase or is that a decrease? That's an increase. Right? So that'll be helpful to us. What is the amount of change? How do we find that? Let's tell me what to do, Saeed.
W minus A, so you get 8.
8. So actually, it's not going to be W minus A, because remember, A is the amount of change. A is 8, like you said. But how did you get it? You said it, what numbers?
20 minus 12.
20 minus 12. So the amount of change is 8. What was the original number? What was the starting number?
12.
12. Now we have enough information to plug into our equation. A is the amount of change. So to be honest with you, I usually do this. Whenever I plug in for A, you don't have to. You guys did the work on the side, you can plug in 8, but I usually, because I want to make sure I know what I'm doing, I plug in the amount of change, the subtraction problem. That's what I do. And then equals P, because that's what I'm looking for, times 12. So this becomes 8 equals P times 12. What do I do to both sides?
Subtract by 12.
What do I do? Divide by 12. And we get 8 over 12 is my percent, which is what? 0.6. Right? What's that as a percent, though? 66. And we're going to round to the nearest tenth. So that would be 66.7%. And we'll say it's approximately P. We're round to the nearest tenth. That's it. It's a 66% increase, which means that it increased by 66% of the original amount. It increased by 2/3. Hey, remember the warm-up we did where we had 8 over 12? Remember that warm-up? 8 over 12 is 2/3. What's 2/3 of 12? 8. So it increased by 2/3 of the original amount. That's that. For you proportion people, here's the proportion work. If you're somebody who prefers the proportion, this would be the work that I would have. The change is A, amount of change. That's 8, right? Original number is 12. P is the percent, and there's 100. And you cross multiply and solve in the exact same way. Okay? Remember, when you do the proportion, you don't have to convert the decimal, but you are going to have to divide by a certain number for certain different numbers. So if you're a proportion person, if you did the proportion, there's the work for you. Okay? I will show you the proportion work. I'm just not going to do it. Let's do the second example. Let's go a little faster through this one. Increase or decrease?
Decrease.
Decrease. Amount of change. 40 minus 24 is 16. Original number?
40.
40. Let's plug into what we know. So A is the what? What does A represent here? The amount of change, which is a subtraction problem, right? Or 16. And what's P?
P.
P, because we don't know it. We're looking for the percent of change, right? It says find the percent of change. Times W, what's W?
16.
It's not 16.
40.
Why is it 40?
Because that's the original number.
The original number is the number we started with. Divide both sides by 40, and that's okay, Saeed. We're making that mistake now so we don't make it later. So what's P? 0.4, and of course we know that that's not a percent, right? So we go 1, 2, put that extra 0 in there, and we get it's 40%. Now is this going to be an increase or a decrease? We want to identify it as a decrease, so 40% decrease, okay? On the last problem I forgot to write increase. 40% decrease. Because it's decreasing, right? What's half of 40? 20. So it's decreasing by a little bit less than half, right? 40 cut in half would be 50%, right? 50% decrease. So 40 cut almost in half is almost 50% decrease. That's how you can gauge if your answer makes sense or not. And here's the proportion for you proportion people. Decrease. There's the amount of decrease. Notice, the 16 was not given to me in the problem, was it? That's the big difference for what we're doing today. Is the amount of change won't always be given to us in the problem. We have to find it. How do we find the amount of change? What's it say in that giant box of information? How do I find the amount of change?
Subtract.
I subtract. If you didn't make a note of that, that's a big one. Now let's get to word problems. In order to find the original amount, okay, the original amount in word problems is not always the number that's given first. We need to look for the thing that took place first, that occurred first in time. It does not always appear first in a word problem. So when we look at this, my 2005 Honda Pilot is now worth $2,500. It's an old car, right? If the purchase price was $20,000, what is the percent of change? So, is this an increase or a decrease? It's a decrease. How do we know? It looks to me like it's going from 2,500 to 20,000. Yep. It's now worth this. It was originally the purchase price. That would be W, right? It was originally 20,000. It's now worth. So it is a decrease. So the amount of change. What's the amount of change? How do we? Instead of telling me what the amount of change is, tell me how we find the amount of change. 20,000 minus 2,500. That's our amount of change. That equals P times what? Careful. P times what? Matt, you got an idea? 20,000, because that's our original amount. All right. So our amount of change is actually what? 17,500 equals P times 20,000. We have to isolate the variable. And we get that P is what percent? Or what decimal, I guess? Hannah? 0.875, which means that that is going to be 87.5% decrease. 87.5% decrease. Anybody got an idea of what a 100% decrease would be? An 87.5% decrease is almost decreased all the entire amount. What would the entire amount of decrease be? No? Just a question to think about what a 100% decrease would be. What's 100% of the original price? Tori? Yeah? Cool idea? She's thinking it has to do with this, right? Move the decimal place over. Great idea. It's not right, but it's a great idea. I love that. What's 100% of the total, of the original price? I actually wanted to answer that question, not just a mumble. You can do it. All of it. What's 100% decrease then? So, what value would the car have after a 100% decrease? $0. 100% decrease would be a decrease of all the value, right? 100% is all of it. 100% decrease would be a decrease of all the value. I just think that's kind of interesting to think about. Okay. Proportion people, here's the work you'd have. This is what your proportion would look like if you're a proportion person. So that's percent of change. What's the key thing to remember for percent of change? It's one big difference. Yep. No, we didn't add or subtract out of 100. We subtracted the amounts. Subtracted the amounts. Now we're going to flip it. So when we're finding percent of change, we're subtracting the amounts. When we're finding the new amount, we're going to add or subtract from 100%. We'll actually have a new percent. So if we're given the new amount, right, if we're looking for a new amount, that means we have to be given the percent of change. On the first three problems, we were given the W, and we could find the amount of change. Now we want to find the new amount, which means we must be given W and the new percent. Careful, you won't be given the new percent, you'll need to find it. How are we going to find it? I just want you to read the words. How are we going to find it? Thank you, wake up. So, on this example, we want to determine what the original number is. Then we want to find the new percent, that would be our p-value, and then plug into our equation, or our proportion. Cameron had 75 songs on her phone, and downloaded more songs and increased the number by 140%. How many songs are now on her phone? We are not, I'm going to tell you right now, we are not going to multiply 75 by 140%. Because it says increased the number of songs by 140%. Well, increase the number of songs from what? From what? From however many she had before. How many did she have before?
75.
What percent of songs did she have? What percent of songs did she have on her iPad? Or on her phone? 100%. She had all the songs she had on her phone. Those are the songs she had. So she had all the songs that she had, right? If I have 10 pencils, what percent of pencils am I holding that are mine? I'm holding all of them. I'm holding all the pencils that I have. It's 100%. She has 75 songs on her phone. That's W. It's the original amount. What percent is the original amount? It's 100%. It's how much she has. You want to increase that by 140%. So what percent does she have now? 240% of what she had before. How did I get that? Well, she had 100% of her songs, right? Then she added 140% to that. So, what's our new percent? 240%. The idea here is A is the new amount, new percent, and original. Okay? So our new amount is what we're looking for. We don't know it. Our new percent is 100 plus 140%. and our original is 75 songs. How do we find the new amount? We add or subtract from 100 depending on if we're increasing or decreasing. We're increasing, so we add to 100%. Guys, this is just like tax. Don't we add tax to 100%? Why? Because we're increasing how much we have to pay by 7%. So what are we going to pay? 107%. Here we're increasing the songs by 140%, so the actual percent is going to be 240%. And tell me what that answer is. I'll put a little X here to make it easier to see. Yep.
108.
180. So the new amount is 180 songs. How can we assess if that makes sense? Well, increasing by 140% is increasing it by more than 100%. When I increase something by 100%, it's doubling. Okay? If I increase it by 100%, it's doubling it. Is this more than double 75? Yeah, it is. Okay. This is the tricky thing. Let's do another example. It might click there. If you're a proportion person, this is the work you'd have. Your new percent is you take 100 and you add or subtract. Why are we adding on this problem? Because we're increasing. The word increase. Great job, Allie, for recognizing that. We're increasing the number of songs. I would imagine on the next problem, we're going to decrease. Hey, remember that 40% we had earlier? It's coming back. All right. We want to determine the original number as W. Nick scored 20 points in his first game, so that would be his original value, right? The number of points he scored in the second game decreased by 40%. Now, A is our new amount. P is our new percent, which is not 40%. Why?
It's decreased.
Decreased by 40%. It's not decreased to 40%, it's decreased by 40%. From what? From 100. From however many points he had before. What percent of points did he have before? He had 100%. That's what he had, right? He had 100%. And this is the original. So we're looking for A. The new percent is 100% minus 40% times the original, which is 20. So it's A equals what percent? 60% times 20. A equals?
12.
So the answer would be 12 points. Now, if it was a decrease of 50%, that would be cutting something in half. Okay? Took the 20, cut it in half. Not quite, right? Didn't quite cut it in half. It's decreased by 40%. If you're a proportion person, looks like I forgot to do the work for that one, so I apologize. If you have a question on the proportion one, it would be A over 20 equals 60 over 100. Where'd the 60 come from? Where'd the 60 come from?
40 minus.
100 minus 40. 100% minus 40. Okay?